All right. Oh, so many faces. Towards the end of the first day. I'm excited. So you have to forgive me if I'm overexcited or like just super happy to be here. I'm excited about serverless, excited about London. This is my first time in the UK. So I am just totally elated, and thank you guys for showing up to my awesome session. Like you said, my name is Timirah James, developer advocate. I've been in evangelism. I've been an evangelist for about 3 years now, so fairly new to evangelism. Have a background, I think most of my career has been spent in mobile development, and a huge chunk of that was spent in iOS development, so primarily in iOS development. And just last year, I became an evangelist for a company called Platform 9 Systems. And I was the developer evangelist for their serverless framework called Fission. And to be honest, that was actually my first introduction to serverless as a whole. So yeah, that was my first introduction to the serverless world. And I was definitely surprised to find that serverless did not mean serverless at all, for it to be so popular. Yeah, if anybody can identify with crossing over, if you're not a DevOps person, right, and you're not used to even worrying about servers, machines, or anything of that nature, maybe you came from front end, so you really didn't have to worry too much about that world. You know about the pain points of learning, diving headfirst into the containerization world and the orchestration world, and then finally coming to a hard stop at serverless. So yeah, that's a little bit of my background, and I'll give you a little more insight into my perspective. So yes, there I am. And that's an interesting photo of me, or photos of me. And I picked that photo because lots of folks, we're still expanding our reach in terms of what Cloudinary does or who we are. And I think this is a perfect example. So Cloudinary, we are an image and video backend service or a media asset backend service. So we provide cloud storage, and we also have like some awesome front-end manipulation features, right? So we call these transformations. You're able to manipulate media assets real-time from the back end. We have some optimization, some cool optimization features as well. We do optimize your sites. We have cool customers with big names. And I thought this was definitely a prime example, and this is going to come in handy a little bit later in the presentation. So today's topic is function composition in a serverless world, right? So when I say function composition, people always want me to specify, okay, what is function composition? So this talk, we're going to go over, what function composition actually is. Why is it so significant? Why do we have to even talk about it? Why is it a conversation? And then we'll go over a few composition styles and structures, and we'll go over the benefits and takeaways for each style. Sound good? Yes, this is a serverless conference. Why am I going over this? I love to go over the basics first beforehand. I'm going to be saying FaaS a lot, so I just want to first off go over what is FaaS, right? FaaS is functions as a service. And basically, FaaS functions enable developers to deploy individual parts of an application on an as-needed basis, right? Why would I want to do that? That approach is super developer-friendly because that allows, that actually strips away the obligation of having to manage or maintain servers. So I like to call it the, stripping away the ops from the dev. Also, it's a great billing model, right? So you're paying for the resources that you actually consume, right? So all the executions that you're actually implementing as opposed to server instance sizes. Also, scaling services is a lot more simplified this way. So benefits, simplified scaling, easier to deploy, and lowered cost. What is function composition? So in my own words, function composition is the concept of creating super function combinations, right? So basically, essentially what we're doing is reusing smaller functions to create bigger, more complex functions, right? So we're basically kind of beefing up our functions for the use of, better complexity. And throughout this talk, we'll go over, the different benefits and takeaways of that. But you'll see has a lot to do with a lot of things, such as latency, such as, your costs, what you're going to be spending, resource consumption, as well as just the overall responsibility that you, the developer, will have in terms of the overall success of your functions and your application as a whole. So composition is super important. So we're going to use this example application. Our example application is going to do something really simple and break it down into two parts. First function, we're going to basically grab an image from the Cloudinary backend. So we're going to fetch that image. The next part we're going to do is transform, what we call do a transformation, right? And basically what that means in Cloudinary terms is manipulate an image, right? So as you can see, our end result would be a crop that kind of complements the picture in a way that it's in a form of it's headshot-esque, and also the huge color change. P.S. Before this, I didn't know gold looked so good on me. I am seriously considering it. I've been pink for 3 years, so we'll see how that goes. No, kidding. So can we combine these two functions into one service? Simple? Absolutely. Absolutely. So the next portion of this talk, we're going to talk about the different approaches in which we'll go about doing that, and why or why not we might want to go about each approach. So let's jump right in. All right. The first one we're going to go over is manual compilation. The second will be direct, or some of you might recognize it as chaining functions. We'll go over coordinator functions, event-driven, and workflows. All right, we ready? Diving right in. Manual compilation. Manual compilation is probably the simplest of the compilation styles, because what are you doing? This is a very hacky approach. We are literally creating a function, one function that we're throwing all the functions into this one big function on a source code level, right? So the FaaS framework is going to recognize all of these different functions as one big task. So in perspective, this is what this looks like. Just on the right-hand side, we have some pseudocode. On the left, we have like a sequence chart. We have our two separate functions. One that's going to fetch the image, one that's going to do the transformation, and then we have this one function that's going to call both at once. We want to do both at once. So the client's sending a request, and that FaaS function is going to do all the functions at once. Simple, right? Pros, simplicity, right? Convenience. I don't need an external framework to help me do this. I can do this at a source code level, right? So, and also there's no serialization overhead for this, right? Cons of this, we only have two functions here, so we may not need to worry too much about, load time per se. But, let's say we have, 10 functions, right? And who knows what we're doing within each of those functions, right? We're calling them all at once. That's going to definitely increase that load time, right? Another con that I want to point out is the inability to scale these functions independently. Why? We're calling all of them at once. Why would we want to do this independently? So let's think about it. So there we have our merged function, right? It's doing everything at once. Let's say we have a client that is requesting only the functionality or the resources of function A, right? In terms of scaling, we have to call function B automatically because we have this one, the FaaS framework is recognizing both functions as one. So again, two functions, still wasteful, probably not, is not too much of a caution, but it is wasteful. But essentially when you're doing this, you're automatically kind of defeating the purpose of the main benefit of using a FaaS framework or FaaS functions, because here you're being really wasteful. The main benefit is to pay for the resources that you're actually consuming. So if I don't need to consume, the resources, the CPU usage or the memory, of function B, I shouldn't have to make an additional instance of this. So, yeah, so that's a caution. The next, direct functions, or again, some of you may have recognized this as chaining functions. This is a fairly common composition style. And basically, simply put, these functions are forming a chain, sort of nested within each other, calling one after the next. So each task is a separate FaaS function, and each function knows the sequence in terms of what comes after it. So how does that work? How does that look? Right? So let's look to the right at our pseudocode. Now it's kind of changed. We have two functions, right? So we're fetching the image, right? And within that fetching call, we're making a HTTP call to our transformation function, right? And then we have our transformation image there. So let's beef it up. If we had an additional function that we wanted to do, like let's say upload, right? So it would look like, okay, we have our get image function making an HTTP call to the transformation function. Our upload function would be nested within the transform image function, and it would be making an HTTP call to the upload function. So that's what it looks like. The client makes an HTTP request to the first function. Function A sends an HTTP request to the next. Doesn't finish until it gets a response from the next function, right? So function A sends a request, wait for the response from function B before it emits a response back to the client. Pros of this, fairly simple. Again, no external components needed here. And again, no serialization overhead for this. Cons are a little bit different. Each function waits for the next function, right? So there's an issue of dependability here. So, and speaking of dependability, now you have to worry about things like, handling failures and fallbacks and retries. Why? Because now every function is super sensitive to the function before and the function after, which leads right into the pains of updating a single function. So if you had to do a major update to one of your functions, now you have to think about the chain reaction that it would cause to the rest of the functions. So it would be a domino effect. Now you have to think about the success of all of the functions that are to follow. So it can be a pain of updating in terms of independence here. The next is coordinator functions. This is fairly common as well. And coordinator functions are additional functions. These are separate functions that act as managers or directors of the rest of the functions, right? The entire execution flow of the rest of your functions. So you're creating a new function that is omniscient, knows all, and it tells all. Says, hey, function A, you're first. Waits. Now function B, you go. Right. And it goes so on and so on. So it's the leader, right? And this composition style is similar to direct functions in terms of communication, or that was probably bad to say, not in terms of communication, because actually all the communication is handled by the coordinator, by the actual coordinator, right? And each other function is not aware of the others, right? So it only waits to be called. So it's totally, oblivious to any other functions. All it knows is, oh, when it's called, it's ready. But it's similar in terms of waiting on another function in order for it to sort of ignite. So this is what it looks like in perspective. So client makes a request to the coordinator. Coordinator is responsible. Say, function A, go. Function A completes. All right, I have a response. Function B, go. Function B completes. I have a response. Okay, the sequence is done. I'm giving a response back to the client. This is great because you don't really need to modify the primitive functions, right? And also, this kind of gives you more control, right? You have more lenience here because now you have a specific function that is going to manage the execution of the rest of your functions, right? And you can manipulate that however you'd like. You simply kind of embed or code the instructions within this coordinator function, and it will handle the execution flow for you. Cons, you have to get, the coordinator function is a separate function, so you have to create this separate function, right? So if you're thinking about costs, it may not be a big deal. You're like, okay, one extra function, right? It handles all this stuff for me. What's an extra function, right? But if you think in terms of, how long this function is going to live, it's the first to start and the last to end. So let's go back to the sequence here. What's actually happening? The coordinator is sending a request, waiting for the response. Sending another request, waiting for the response. And it doesn't end until the sequence is actually through. So again, for this example, not too much of a worry because we only have 2 functions, right? Let's think about 50 functions. Let's think about 100 functions, right? The coordinator is sitting there waiting for that 100th function to send a response back before the client even gets a response, right? So there's a lot of idle time there, and in terms of just having, idle resources just sitting there, it might be a little bit costly. It may be a little bit of an inconvenience because you don't know how long that client is going to be waiting for that response. So for these next 2 composition styles, right, they're a little bit different. Starting with this event-driven composition style. For event-driven composition styles, it's basically, we're switching the ideal flow, right? So before, we're talking about, in terms of just computational data, right? In this instance, we're thinking about the data flow, right, instead of the control flow altogether. So basically, there are functions that are emitting and reacting to events on message queues. These functions are, triggered by events rather than these specific functions, right? So these events that are on message queues, and they're joined together by mapping the request queue of one function to the response queue of another function. So it's solely based, the communication is solely based or embedded within the message queue. So they basically watch for certain events to happen before they execute, without really knowing, which function or who emitted that event. So this is what it looks like. So there's an event that is sent off into the message queue. Message queue sends that event on for a trigger to start the first function, right? And again, they may not even be in order, but for this example, to trigger a function. So everything is coincidental here. I want to kind of capture that. Everything is sort of coincidental. So if there is, if this function, so this is what it looks like altogether. So function A just coincidentally emits an event that triggers function B, right? Function B doesn't know who it's relying on, who is emitting this event that is needed in order for it to start. So everything is kind of happenstance here. It's all about data flow, right? So everything is solely dependent upon data. Again, so with other composition styles, we specify the order of composition explicitly, and stating the control flow. Here we've kind of switched our focus again. So function A is triggered, it runs, it completes, and is published again onto the queue. This event triggers function B only because it is triggered on that specific with that specific event. Pros of this, if you know anything about messaging queues or message queues, it handles the communication for you. The communication between the functions handles the communication for you, also handles error handling and things like that for you as well. Also, the decoupling of functions, right? So they're not dependent upon each other per se. They are dependent upon certain events that are represented as data, right? In order for them to ignite and then ignite, complete its run, and then be published again. So there's this decoupling and there's this sort of independence from each other. Also, this is really commonly used. You've probably seen this several places. This architecture style is very, very common. Cons of this. The structure of these implicit compositions, it can become difficult to understand and even dangerous to even, add or remove functions because they might, be used to depend or be used to, they might be a key to igniting another, they might have some data that, that is essential for another function to live. So it's kind of hard to understand the entire flow, right? Again, we only have two functions. So let's say the average enterprise application, right? We're talking about 10,000 lines, 10,000 functions. We're talking, to keep up with the structure and the flow of everything, it can be a little bit difficult. So, and that's what I meant by, web of implicit dependency. So literally a web trying to figure out, okay, if I remove this function, is that going to, is that going to kind of throw off a couple of these other functions? Again, so difficult to version or upgrade functions. So if I update this, the data is going to be, the output is going to be different. Okay, so maybe it won't trigger another function, right? So there's this like catch-22. In one sense, there's a decoupling of the functions, but the functions are dependent upon the data, right? So if you're taking away this, the functions that emit this data that is responsible for triggering another function, now you're in a bit of a catch-22. So this next style is workflows. Any of you ever heard of workflows? Workflows? I see her. She's heard of workflows. Me and you. So workflows. I want to say it's fairly new to the composition trail, and it's becoming a little more popular these days. And this is basically, creating a visual flow chart of function interaction. So you can actually see, the sequence of the communication from start to finish between the functions. So basically, it is an approach that uses like a new runtime framework to execute this visual flowchart for you. And here a function will only begin to execute once its dependencies are done. Workflows are everywhere. In terms of, from business processes to data pipelining to DevOps, again, it's fairly new composition style to the trail, but it's becoming more and more popular. So it's definitely making its way through on definitely these three categories here. Have any of you ever seen some workflows of some of these folks? Yeah, very common notion used in many domains. Yes. So essentially, this is kind of what it looks like in terms of sequence. I'm just kind of showing you the flow. But you know what? I should have just. Well, that was good. Actually, this was good. This is a great representation here of what the visual workflow would look like. So in terms of communication, this is what it looks like. Client makes a request to the workflow framework. Workflow framework makes a request to the first function. First function sends an immediate response, and then the workflow framework sends to the next. So again, the workflow framework is acting also as a director as well, because there should be a flow to this, right? Hence the flow chart, right? So first this, then that, then that, then that, before everything ends. So this is super similar to, a coordinator function. Instead you have like a whole workflow engine doing this for you and managing the communication and the sequence for you. Let's see. Do I have any other comments about this? Again, the client doesn't communicate directly to the functions. Instead, it just submits a task to the workflow framework. There he goes, yeah. So pros of this. There's a centralization of the logic going on, right? Logging, visualization, so everything's happening. The engine kind of brings everything together, right? And the functions are loosely coupled. So again, there's a sequence happening before and after, but they're loosely coupled, so they're not 100% dependent. And workflows, again, handles the communication, the complexity, the latency, the retries, the failures. So all of that is handled within the actual workflow engine. And this improves performance. So if you kind of see, you kind of know what to expect, right? There are no surprises, like what we had with the event-driven composition style, right? So we know the sequence and we know the scheduling of each action, right? So not just, how it's supposed to happen, but just the actual scheduling of everything, if that makes sense. Yeah, so operations, basically, it definitely handles operations such as making sure, the data goes in the right place at the right time. So again, helps you with all of that scheduling, and everything is handled within the workflow engine. Cons. This is considered an infrastructure, right? So there's that infrastructure complexity. There's not too much control that you might have over it. Everything is handled within the engine, right? And usually, I would be safe to say that with all workflow styles, right? So all platforms, there are several different, companies that have implemented this or provided this workflow composition style for developers. You usually need to learn some workflow-specific language, right? So like YAML, right? YAML, which is always fun. ASL, right, for all my AWS folks. DSL, there's always some workflow-specific language that you need to be privy to, right? It can be annoying if you're using a new, you're using a new service, right? So AWS, it's YAML-esque with the ASL. But it's different from YAML. So you have to kind of be privy to different languages depending upon which platform you're using, and the workflow engines work differently. Here are a few examples. AWS step functions, which I've heard being used several times throughout the conference, even today on the first day. AWS step functions is becoming actually a lot more popular. Azure Logic, as well as Fission workflows, right? So while I was at Platform 9, I was on the team that kind of helped implement and kind of helps build the workflow engine for Fission. So yeah. Can you mix match? Okay, yeah. Absolutely. Oh, I love this guy. He's like, I think we'd be friends in real life. We walk around conferences doing this all day, scaring folks. But yeah, you can mix and match. It is all depending upon, as you can see, there's this trend of what works for you. What is a is a concern for you as a developer, right? Or a concern for you, on your teams, right? Is it actually cost? You might not care about that. Is it actually, latency? Latency is a big thing to worry about. Can you mix and match depending upon your applications? Absolutely. A great example. I've heard Katie be mentioned several times. I don't know how many of you have seen this talk, but she was talking about Saga patterns, using AWS step functions. So, and I believe with this, the example she used at this conference was basically, I believe it was like some trip, some sort of like a trip scheduling application where you could book your hotel, book your flights, and book something else. I don't know. And she used step functions. And she used a state machine as the coordinator to actually manage the step functions. So again, you can mix and match according to convenience and what's important to you. So I thought it was a great example. Yeah. And I believe the Saga pattern is something that is conceptual and not yet implemented. But yeah. You can ask Katie to confirm with that. Approaches. So we're just going to recap. That was a lot, right? There was like 5 different approaches, but that was a lot to handle. Some was, very different. Some almost too similar. You can't really even tell the difference, right? Manual compilation. Simply put, do it at a source code level. If you're a hacky kind of person, maybe you don't have 1,000 functions. Maybe you only have 2 to 3 to 5 functions. And it's okay to call them all at once. And it might not make too much of a difference if, or you might be 100% sure that the client's going to want all of these, when it makes a request, it needs all of these functions done at the same time. And it would be, you don't need any external frameworks to accomplish this. So you might want to just go for manual compilation. That's great. Direct chaining functions, right? It's a very simple structure, right? You have one function that is calling the next. Each function is making a regular HTTP call to the next function, right? So that kind of handles a little bit of structure, right? But then again, there's some dependency there. Now you have to worry, if you have to update a function, now it causes the chain reaction, the domino effect, right? You have to really, how much of that operational complexity do you really want? Do you want to be responsible for the fallbacks and retries and, worry about that for each and every function, right? So there's a give and take there. Coordinated functions handle the communication for you, the execution flow of all of your functions. So you don't really have to worry about the communication between the functions. The functions don't even know about each other, right? The coordinator is the director and is handling all of the communication, right? So one by one by one. But how long is that coordinator going to be sitting there, right? So how many functions do you have? How much time are you willing to spend? How much time do you, depending upon which platform you use, you don't know how much, time you have in terms of the lifetime of a function. Event-driven. Now you have a message queue, right? That's going to handle the communication. It's going to handle the, the error handling and all of that for you, right? But depending upon how big or complex your application is, or applications are, how many functions you're going to have, you have to worry about, there's a catch-22. You don't have to worry about dependency on functions explicitly, but then on the other hand, you have to worry about the dependency on the output, right? So the output of one function may be an event that's going to trigger the next function, right? So if you remove that function, now that function might never start. So now there's this catch-22. Workflows, you actually have, if you're a visual person, you have an actual flow chart that is generated for you, right? You have an engine that is working for you in terms of managing the communication of all of your functions, right? And also, it's also handling the scheduling for you. So not what goes where, but when it goes where. Also, right? So all of these things are managed for you. And what are some cons of workflows? There's this additional structure, right? You got to do a little YAML, right? Or maybe it's, with Amazon, it's ASL. There's this other language that you have to there's a little bit of a barrier there if you feel like sitting down and, doing some additional trial and error and reading and all that stuff. Because YAML's so fun. So that's a little bit of the recap. All of these things, you have to kind of figure out which approach should you use. It's probably the most important question. Again, the question, the rebuttal question to that is what's important to you? What is important to you as a developer, right? What is important to your team, right? What is it? Is it cost? Is it latency? Latency is a huge factor, of course, but how much latency? Maybe you're willing to give a little, right? Depending upon the convenience, right? Depending upon the complexity of your projects, of your applications, of your functions, right? So each come with their own pros and cons, and you should definitely consider using multiple approaches. That might be ideal for you. Some cases work for multiple function styles and some don't. And my suggestion is, try them all, Work with them. Do an example project. Hello world. Try multiple functions. Try out my example with 2 functions, right? Try with Cloudinary. My example with 2 functions. Then try 10 functions. Try 20 functions and see, where you're willing to give a little and what benefits matter to you the most. This is a repo, actually, that I worked on while I was at Platform 9. This is Fission's function composition demos. So we have a few, I have a few composition patterns that I worked on for you to try out. So yeah, so that would be awesome. If you have any questions, you can send them to me. Also, I'm on Twitter, @TimirahJ. You'll see it at the end of the slides. Tweet me, follow me. I will follow you back. I will retweet you. If anything sparked your interest even remotely, please feel free to tweet it. I love it. I live for it. I'm an evangelist. This is what we do. So, yeah. Also, serverless is lit, okay? Serverless is lit. Do we agree? Okay. Only some of you. Some of you just had a free day, free 3 days. You wanted to come to a conference. All good. That's all I got. Thank you.